Okay, so we are on lesson 1-5. We are going to be learning about something totally different than place value or exponents or powers of 10 or any of that. We are moving on to addition properties and subtraction rules. All right, so let's look over here at our objective for this lesson. We want to be able to, by the time this lesson is done, use addition properties and subtraction rules to add and subtract multi-digit numbers. All right, no problem. So let's start with number 1. This is our first addition property. It is called the commutative property of addition. I'm going to stand in front of you because I don't want you to see what it is. Because I want you to think for a second. Commutative property of addition. It's kind of a rule. What word do you hear when you hear the word commutative? It's a property or a rule of addition that is called the commutative. What word do you hear in there? Commutative. Romy? No? Abby?
Community.
What is it?
Community.
Community? What other word do you hear? Commutative. Yes? Commutative. Yes?
I don't know.
How about the word commute?
Oh,
Has anyone ever heard the word commute?
No. Yes.
Jackson, what do you think it means?
Like, you might make your commute to work or school in the morning.
That's exactly right. To commute somewhere means you go back and forth. I may live in Cape Coral, the school is in Fort Myers, so I might commute back and forth. Or some people live farther away. Maybe you have a job that's in Port Charlotte, and you commute back and forth. So you change your location when you commute. So what do you think the commutative property of addition is? Yes. Something's going back and forth. The location of something is going to go back and forth. Romy?
So it's the two numbers, but you just keep on switching them.
Ding, 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 ding. The commutative property of addition. Changing the order or the location, like they're commuting back and forth to work and home, changing the order of the add-ins does not change the sum. That's the rule. If you say 8 plus 7 equals 15, and you change them, or they commute, 7 plus 8 is still 15, right? Is 2 plus 3 is what? 5. 3 plus 2 is also 5, right? Does it matter if I say, I have 3 things in this hand and 2 things in this hand? How many things total do I have? 5. Now, I have 2 things in this hand and 3 things in this hand. How many total do I have?
5.
Does it matter which order?
No.
It does not matter. They can commute back and forth and back and forth. And it doesn't matter. You still get the same sum. It doesn't matter if you had this first and this next or vice versa. So that is called the what property? Commutative. You're going to need to be able to look at a problem and label what property of addition that it's resembling. Okay? Commutative property. That's a pretty easy one. Let's do the next one. The second one, I'm not going to show it to you quite yet. You're going to try and figure out what it might mean. It is the associative property of addition. Okay, don't look in your book.
We learned this.
Some of you are looking in your book.
We learned this in 4th grade.
Okay, so hopefully you can remember it from 4th grade. What is the associative property of addition, those of you who have not looked in your book?
We learned at the beginning of the year.
Yeah, and then I kind of forgot it because it was straight in the beginning.
Okay, so who remembers? Associative. What word do you hear in there? Associative. What's the word that's in there? Kayla, thank you for raising your hand. Associate or associate. If you associate with somebody, you kind of group together with them, right? Or if I work with all my associates, it's my group that I work together with. right? So Mrs. Engelhart and I are kind of associates. We both teach 5th grade. We kind of like stick together. We group ourselves together, right, as a team. And then the 4th grade teachers are kind of associates. They kind of group together. Okay, so what would the associative property of addition, do you think, mean? Has to do with something about grouping together. You think you know? Take a shot at it.
I was going to say sorry about you were missing the word.
Oh, you were? Go for it.
You, the 5th graders and the 4th graders, and then miscalculate the period 5. Or the
Yes.
period 5.
That's right. You do say that. Okay, so who can think, let's pause for a second, who can think of how that would have to relate to adding up numbers? Grouping things together. What rule might there be? Anybody pull it back?
Like you group things, they group numbers.
Yep, you're exactly right. You're going to group numbers together. So look at this rule. The associative property says regrouping addends. What are addends? Do we know what addends are?
Sounds like
You remember? Like, here we go. 2 plus 3 equals 5. This is an addend. This is an addend. And this is the, what's the answer to a sum? Thank you. Addend, addend, sum. So, the associative property says this. I want all your ears really paying attention. Look at this. It says it does not matter. I'm going to make this a little bigger so you guys can see it. Okay. Did it get bigger?
Yeah.
Way bigger.
No.
Oh my. There we go.
Scary.
Now it's really big.
Now it's gonna be hard for you to cover.
That's all right. Look at this. Regrouping the addends does not change the sum. So first we had changing the order of the addends doesn't change the sum. And now we say you can regroup them and it doesn't change the sum. So look at here what they had. Here's the example. 9 plus 4 plus 6. So first they did 9 plus 4 grouped together and added the 6. But then over here, they did 6 plus 4 together. Do you still get the same thing?
No.
If I have 9 things and 4 things and 6 things, and first I add the 9 and the 4, and then I add the 6. Do you get the same thing as if I added the 4 and the 6 together and then the 9?
Yes.
It doesn't matter what order or how you group them, because all that matters is you're adding them all together. Why do you think you would ever want to change the way you group them? 9 plus 4 plus 6, that just works. Why would you ever want to add 4 plus 6 first and then add the 9? Why would you use the associative property? I want everybody to kind of think of that. I only have one person with a thought on that. Look up here and think, why would you want to group the 4 and the 6 first instead of the 9 and the 4? Why wouldn't you just do it in the right order? Why would you look at that problem and say, I'm going to add the 6 and the 4 first and then add the 9? I may call on somebody with their hand down because I want you to be thinking. Why do you think? They said, rather than do it in order, I'm going to do these ones first and get that answer and then add the 9. Why would they do this instead of this? Instead of taking 9 plus 4 and you get 13 and then add 6 and it gets to 19. Here they were like, oh, I'm going to add the 6 and the 4 first and get 10 and then add the 9. Why would you do that? Cart.
There's no difference. You're gonna get the same answer
True. You're going to get the same answer. So why did they do it?
because actually I don't know.
You don't know? Romy? Nope. It stays the same. Kayla?
Because 4 and 6 make 10 and 10 is easier to add to.
That's exactly right. You can group things together to make it easy for yourself. Is it easier to take 6 and 4 is 10 and then you get 9? That's a little bit easier than 9 plus 4 is 13 plus 6 more is 9. It's easy to add 10 to a number, isn't it?
Yeah.
Yeah, because you just add the 1. So this associative property says group whatever numbers together that make it easiest for you to add it. Okay, that's our second one. You think you got those separate in your brain? Commutative means changing the order. Associative means changing the groupings. And our last one is the identity property of addition. Identity property says this: the sum of 0 and a number is still that number. Think of it as identity, like I am Mrs. Van Zanten. If you add nothing to me, I am still Mrs. Van Zanten. It's my identity. It stays the same. If you don't add anything to me, I stay the same. Those are the 3 rules: commutative, associative, identity. You think you could recognize them if you saw a problem? Well, we'll find out, won't we? Okay. Now we just have a couple rules of subtraction, and then we're going to see if you can recognize them. So here we go. The rules of subtraction. Let's pause for a second and make sure you know how to label a subtraction problem. If you have 9 minus 4 equals 5. What is this? What is this? And what is this? Okay? This right here, the first number in a subtraction problem, is called the minuend. That's a big word. It's called a minuend. What is this one called? It kind of sounds like subtract.
It says it right there.
Oh, right here, look it. Oh, I get it. It's giving you a little cheater right here. The minuend.
Minuend does not sound like subtract.
Minuend, but then the second one that you're subtracting is called the subtrahend. The minuend minus the subtrahend equals the difference. An addend plus an addend equals the sum. A minuend minus a subtrahend equals the difference. So you need to know that because listen to this rule. Here's the rule. Rules of subtraction, we've got 3. So let's listen. When the minuend, or the first number, is equal to the subtrahend, the difference is 0. Well, of course. When the minuend and the subtrahend are the same, it's going to be 0. If you have 7 and you take away 7, you're going to have 0. So whenever the minuend and the subtrahend match, the answer is 0. Easy peasy. How about this one? When the subtrahend is 0. When the thing you are subtracting is 0, the difference is going to be the same as the minuend. If I say, I am Mrs. Van Zanten, I take away nothing, I am still Mrs. Van Zanten. Got it? 57 items, you took away 0, and you still get 57. That is the rule. When the subtrahend is 0, the difference, or the answer, is going to be equal to the minuend. And the last one we've got, when finding an unknown added. This is probably the one that is the hardest. These two are pretty simple. You really don't need a rule for those. This one, you've learned this, but let's do a recap. When finding an unknown addend, okay, so like an addition problem right here. This is an addend, this is an addend. And this one is unknown, right? I'm missing a few of your eyeballs. When you have an unknown addend, you can think of it as a subtraction problem and go backwards. 4 plus what equals 11? Think backwards. 11 minus what equals 4? 11 minus 4 equals 7. Got it? Let's try a few examples. All you can do is go backwards. If you have 4 apples plus more apples and you get 11 apples total, what's that missing number? You can think of the addition problem backwards as a subtraction. 4 apples plus how many apples equals 11 apples? You think 11 minus the 4 equals 7, right? 11 minus 4 will give you that number always, the opposite. Let's try a few examples. I think you guys are going to do well at this. It's not too difficult. Let's do some practice.